In the previous one, Y parameters, admittance parameters in two-port networks we studied. Now we go for transmission line parameters or T parameters or ABCD parameters. The transmission line parameters also called as ABCD parameters of a two-port network. ABCD parameters are useful for analysis of transmission lines. Transmission lines, ABCD parameters, telephone systems, radars, microwave networks. These are the applications. What are the applications of ABCD parameters or transmission parameters? Analysis of transmission lines, telephone systems, radar, microwave networks. These four applications you have to remember for 2 marks questions may come. The ABCD parameters also called as cascade or chain parameters. Find the cascade parameters. Sometimes they will give the question like that. Find the cascade parameters for the network shown below. Cascade parameters in the sense we have to find transmission line parameters. Consider a two-port network having input port is having voltage V1 and current flowing through input port is I1 and I2 is the output port, V2 is the output port voltage, load may be connected. V1, I1 are the independent variables, V2, I2 are dependent variables. We are writing in transmission parameters V1 as a function of V2, I2, I1 as a function of V2, I2. The transmission line parameters are defined by the equations. These two equations we have to remember for any transmission line parameters. Sometimes they will give one problem. Find the transmission or chain or cascade parameters. Then we have to write V1, I1 equations. These two V1, I1 equations in terms of V2, I2. In terms of V2, I2, we have to write V1 equal to A into V2 minus BI2. I1 equal to CV2 minus DI2. Where ABCD are parameters, those have some names, ABCD, transfer impedance, like that. If you represent this V1, I1 as a matrix form, V1, I1 equal to ABCD, V2, I2. Substitute I2 equal to 0 in equation 1, then you will get, if the I2 equal to 0 in the sense, this is open circuited. I2 equal to 0 when it becomes, when output port is open circuited, then V1 equal to AV2, A equal to V1 by I2, where A is called as open circuit voltage ratio. This is called transmission parameter A. Open circuit voltage ratio is called as A. This name also we have to remember. Find open circuit voltage ratio. Find A equal to V1 by V2, where A is called as open circuit voltage ratio because we are open this voltage, open circuit this voltage, and load is removed. Therefore, it is called open circuit voltage ratio. Substitute I2 equal to 0 in equation 2, then D becomes 0, you will get C. C equal to I1 equal to CV2, from that C equal to I1 by V2. This means I1 by V2, C is called transfer admittance. A is called as open circuit voltage ratio, C is called as transfer admittance. Similarly, if you substitute V2 equal to 0, V2 equal to 0 when you have to substitute when this is shorted. When it is shorted, you can substitute V2 equal to 0. Substitute V2 equal to 0 in this equation 1 and 2. Then you will get, substitute V2 equal to 0 in equation 1, you will get B. B equal to minus V1 by I2. What is B? It is the ratio. V by I gives impedance. But it is a negative. Minus V1 by I2 you will get. Where B is called as negative short circuit transfer impedance or transfer impedance. It is. Simply we can say transfer impedance. Define transfer impedance. 2 marks questions will come. Transfer impedance is the ratio of V1 by I2. Minus sign indicates that it is a negative short circuit transfer impedance, also called as transfer impedance. Similarly, substitute V2 equal to 0 in equation 2, you will get D equal to minus I1 by I2. D is called as reverse current gain. I1 by I2, it is a current ratio. I1 is the input current, I2 is the output current, output port current. It is called as gain, reverse current gain. It is. Output by input gives gain actually, but it is a reciprocal reverse current gain. It is actually any gain means what is meant by gain? Output by input. Output by input gives current gain. Output by input, it is oppositely. I1 is the input, Therefore, it is called reverse current gain. Therefore, the transmission line parameters are these are the four. You have to represent A equal to V1 by V2, B equal to minus V1 by I2, C equal to I1 by V2, D equal to minus I1 by I2. It is called reverse current gain. It is a V1 by V2 is voltage ratio. Similarly, transfer impedance, transfer admittance. Determine transmission line parameters. For a S domain also you can calculate. Let us see that.